Hello and welcome to today's webinar, as usually hosted by the Open Telecom Cloud Community Portal. As you can see already here on the first slide, we have a pretty interesting topic for you here. It's called Mastering the Flood of Logs in Distributed Architectures with the Log Tank Service, the LTS of Open Telecom Cloud. This topic is brought to you by two of our Open Telecom Cloud members. At one hand, Christian Bölle, at the other hand, Sandro Simet. You will get a few more information from them and also about them in a second. I would at first hand over then to Christian. So thank you a lot for joining today, and let's have a great, productive and informative webinar. Thank you a lot, Christian, and also Sandro for having you here, and let's rock.
Right, Stefan, thank you, and thank you for having us here. So just a short introduction. So I'm Chris, or Christian. I'm the product manager in OTC for the compute and platform services. As well, we have Sandro. You can also introduce yourself.
Yeah, hi in the round. I'm the product owner of the PaaS Squad, and not only responsible for LTS, but also, for example, APIG, Function Graph, DMS, DCS, CTS, and AOM and APM. Thanks for having me here.
All right, thanks. I think then we can already start into the content. So what we have prepared for you in this webinar is a short introduction into the LTS service, what features, what integrations do we have, and then we have brought, I would say, two deep dives, and these deep dives where we will demonstrate how does it work, how to configure the things, how to set up things, how maybe also overcome some challenges what you will face. And then at the end, we will talk shortly about the billing and the costs connected to LTS and what's next. So what are we planning now on the features of the roadmap of the Log Tank service? All right. So let's start. What is LTS? A short introduction. So the LTS itself, I would say this is a universe, I call it. We have three things what we want to talk about. One is the features of the service itself. So we talk about collecting logs, log analyzing, putting alarms on top of it, transferring logs, all these kind of actions what we do. And then we talk about ingestions. Ingestions means where do we source log files from? So the three major sources of LTS you can see here. This is the ECS service, also the virtual machines which are running in the cloud, the container service, and the CCI. These are the container instances. So a short word about intra-region hosts and extra-region hosts. So why do we separate them? So an intra-region host means everything which is running as an ECS instance in one region. Also, so you have a server, you want to monitor log files of a server in EUDE, for example, and an inter-region connectivity covers everything by you have servers in one VPC, you have servers in multiple VPCs, you have servers in multiple projects. You can connect to one LTS, as even you have multiple tenants. So you can have, for example, one tenant where you install where you operate the LTS service, and you can stream them from 5, 10 other tenants into this one instance, or you can even separate them. So tenant-wise, project-wise, and VPC-wise, you can do it in one region. Extra-region hosts means then for us that you want to maybe collect log data from sources outside a region. Means could be an edge setup, a local data center, could be other regions, could be also other cloud providers. And this is right now great. So this is where we are working on. So we'll talk about that later on. So this is the where we source data from the workload systems. The other part are the integrations into our cloud services itself. So we have connected our cloud services directly to integrate with LTS. For example, we have the API gateway, the load balancer, the firewall. We have data warehouse system, DDS, CTS already connected. There's more to come. We are working on this. As you can see, for example, the anti-DDoS service will come soon, but also more will come. So this is the I would say the overview what you can do with LTS. It's the idea that you have one central place in your cloud infrastructure to connect or to collect all the logs from all the services you are using, that you then can perform powerful log analysis, end-to-end traces, and this kind of activities. Okay, then let's jump already into the first deep dive, what we prepared. So what is that first deep dive? It's a setup what we have generated on OTC, which is the API gateway, which provides the a published API in the internet. Behind this API gateway are a couple, there's a VPC channel, so-called, it's more or less a load balancer, which connects in our backend systems. And we are now interested in what happens in the API gateway itself, because it has a native integration into the LTS service. So we have this so-called access log, which is directly streamed from the API gateway to LTS. And then we have multiple ECS servers behind the API gateway, which are then doing actually which are really processing the API requests to our backend systems. And we want to monitor the detail there. Also, we want to monitor systems, we want to monitor the application servers which are running on it, and we also want to monitor the logs if something goes wrong. Okay, so we have prepared this setup already. And also, maybe I want to explain one more thing. So the LTS service has the central part, also the LTS service itself, and it has a so-called IC agent. This IC agent is the part which is installed more or less on your systems to connect to the LTS. Also IC agent is a small daemon which runs on Windows, for example, or Linux, or even on a container node, which is responsible to collect the log files from the local system and sends it into the central system. So this IC agent, in the example we have already installed, it's a simple installer, which is in the documentation, but this service need to be installed and active to be able to collect log files for LTS. Okay, good. Now let's jump into the console. And in the console, when we activate the LTS service, we will find it here. And the LTS service in general consists out of so-called log groups and log streams. So what you can see here now, there are multiple log groups which I've created for the demo. And here inside there are the log streams. Log streams are actually the entity where a type of log are collected. Also, for example, in this demo plane Ubuntu, I collect all the system logs of all Ubuntu servers of a specific ECS group. So we will see that later. And this is grouped into a log group because I want to see all these logs together. You can freely decide which groups you need, how many streams you want. Do you want extra streams for some systems, or you want to combine them together? This is completely free. How you can set this up. And when we now look into the so-called, there's one configuration item which I want to mention, which are the so-called host groups. Host groups are a useful feature from LTS. So as you can see, for example, there are two ECS services running behind the API gateway to serve the request of the API gateway. And if I now set up a configuration, I'm interested in logs of the Ubuntu servers. You know, I don't want to do it for every server itself. So what I do is I define a so-called host group in LTS and say this configuration is applicable for all these type of service. So I configure a host group, then I only assign these groups to it, and they are all owned in the same configuration. Means I can also show one of this configuration in the ingestion management. I can see, for example, here I have the syslog under Ubuntu configured. How does it look like? I want to collect from the local Ubuntu systems everything under var log syslog, that I know what the systems are doing. And this I activate then for all hosts in the specific group. So I don't have to, when I start now a third, a fourth, and a fifth ECS system, which are also Ubuntu systems, I just have to add them here into the same host group, and they automatically inherit all settings for it. And as you can see, the status here, also the IC agent is running of all the systems, and it has a specific versions, so that you can know which version of the agent is running there. All right. So now enough about the setup. So let's look into how does it look like. So let's go to the log stream of the syslogs. What do we get? Well, what you can see here is actually this is the log stream for the Ubuntu for the syslog, and you can see whatever the systems are logging. So you can see multiple things. You can see which host is part of the stream, what is the IP address, what is the source of it, and you can see the log statement itself here. So what this Ubuntu has written into his syslog. Now, the challenge is, I think, as you can see, we can't really do much with it because we get the full line of a log entry of the system here. But we want to specify, for example, we are interested in a specific service. So what we have to do is we have to give this log a structure. So this structure works in a way that I can configure this log stream in a way to say, I'm interested in specific fields of it. Now, what you can do, how to define a log structure is more or less you can use regular expressions. You can use JSON, also if you have a JSON-based log file, at the limiter-based Nginx, and also structuring templates. So we will come to that later. But now we want to do today here, let's start with the regapps. So there's a very useful tool in the LTS service to do so. For example, I can select one of the last log records which the LTS has already received. I use now this, for example. I use this as an example, and now, you know, sometimes regular expressions are a little bit difficult to handle, and it's also sometimes it's a little bit challenging. So what we have here is a very nice integration to help you to define your regular expression. So you mark the field which you want to have, then you can give it a name, like this would be the timestamp of the syslog. Then you want to know maybe this is the host, and this is the host name. And then you want maybe to add, this would be the user, or the daemon. And now what you can see is the LTS itself is actually building a regular expression for us. So you can also manually enter this completely yourself when you like regapps, but sometimes it's also a little bit challenging. So this tool is very nice. It gives the indication how the parser will work now, and this log structure will be activated. So we can save that. And from that moment onwards, now all the incoming log data will be placed into this new structure. So let me shortly go to the system. Let's motivate the Ubuntu to write something into the syslog. So now we have restarted the system, and all the new data which will now be received, you will see now are parsed into hostname, timestamps, and so on, and all these kind of things. And this now enables, for example, that we can do quick searches. With these quick searches now, we can see what fields are filled, with what values they are filled, what kind of hosts are used, and so on and so on. So we will see this also later on. So the first thing is always that you define a log structure. The log structure we have now defined here with a regular expression. This is a very basic way how you can use it for example, for all the systems which run a log file which just have one line per record. Now the next example I wanted to show you is when we have this API gateway here. So we have now just only monitored the system itself, but we haven't called the application itself. So what we can do is we can call the API gateway this is an example API where you can see the locations of our data center and what is the current weather condition. This is the functionality of the API. So this API we have called now. This has been worked and perfectly fine. We get the data out. And now what we want to do is, like, I want to show you two cases, what we can do here. For example, when I go into the development area, I can simulate that the API gateway is throttling the calls. For example, here it's only allowed to call the API 5 times per minute. So what I do now is I call this API a couple of times. And as you can see, after 5 times now, the API gateway is blocking already the request. So it's a throttling limit reached. This is the one example. We will see now later in the logs. And the other example I want to show you is that here with this geodata hide, the API returns no geodata. So we can also use the show parameter in the API, and this then the API reveals in addition the longitude and the latitude of the data center locations. That's a nice feature. But what happens is if I give here any other value which is not known to the API. So we do this, and what happened now is that we actually produced The API was not capable to handling this, so in the backend system, a runtime error has occurred, and now we can see what happened in the logs. So what we now can do is we can look into the logs. So the application log files are here located, and let's look into the log file of the application container. And as you can see here, here's the exception. It says, okay, the geodata parameter was used webinar and I can't handle this. And it returned then into a runtime exception, and it used the Seabury log because the application can't handle this parameter. So now we can look into the LTS. LTS also is not only monitoring Ubuntu, it's also monitoring our application service itself. So in this log, you can now see exactly what I have shown on the console. You can now also see here. And what happened now is that we see this, there are some info statements, but as you can see here, this log is it's written into here actually the entry starts of the log, and then a lot of information comes in multiple lines. So what we actually need is we have to change our ingestion pattern, and this works in a way that we can go here and see this log file from the Tomcat application server is not a single line log file because it uses multiple lines. So what we can do is, like a single log in Ubuntu, we have now to use a multi-line log. And a multi-line log, here is a small article what we just published in the morning, by the way, where you can see all the examples which we use today in our demo. And this ISO date format, which is used by the application server, we can also use here as a regular expression. We can build it here into the multi-line log format. With this, we inform every client which parses the information from a Tomcat. Oh, the Tomcat is using a multi-line log, and this is how the log starts. So what we do with this regular expression, give me 1 second, I just submit that. We inform the log collector, the IC agent on the system, that it has not to look only just in a single line. It has to look for exactly this pattern, and this tells him this is when a new line starts. So now, what we can see here is, here everything was a single line, but this was wrong in the log file, so we can't pass our log in the right way. So what we can do now is, as we have updated it, we can try it once more. We produce the same error again. Now we have webinar 2. We look into the log file. We have again the full stack trace of this problem collected by the application server with webinar 2. And now let's go into the LTS and see what happens. So as you can see, as you can see now, the problem is gone. Because now there's one log statement which was a warning. Warning means the application server is running into the abort situation of the transaction, and zero is then the problem itself. So we have now one log statement covering the full exception with all the lines included, instead of having for every line a single record. So this is a really good feature which you will need, especially when you use also standard out parsing from the container applications, because the log file itself, it's containing multiple lines and multiple threads, then writing multiple lines into it. So this is a very useful feature. So now as you can see here was the problem, and the one more item I wanted to show you here, what is a very useful information, is that you can access the so-called log context. Log context means the LTS, it brings to you a view here. When you select a specific log record, you can see what happened before and after this problem. And this is very useful. So I can determine this was the transaction which failed. It has a severe problem. It has a runtime exception. And before, the warning was that the application server tries to go into a fail recovery mode. But it couldn't complete it, so it failed with a CRE statement. So, and this is now the very nice add-on, I would say, as we have the thread name here, because the application server runs a couple of hundred threads in parallel. So we can filter the log itself for each thread. So we can be very sure that we can follow the log for every application server, for every thread, without having the problem that thousands of log statements of thousands of threads are bombarding us, as it will happening when it's just into a file. And the other topic I wanted to show you is that we have a unique transaction ID. This transaction ID is given by the application, by the API gateway, when the request comes in. And for this request, I can also do a filtering, for example, and I then see the entire context of a transaction. So this is very helpful, because then I can identify when the transaction started, when it was ended, and what happened in between for this transaction. So this is the log context, which boils, I would say, the information down to really what is needed when you try to debug a transaction. This transaction ID, by the way, I can use also when I use the LTS query page. For example, I can just do a full text search the entire log for this transaction. So you can see now this transaction was logged actually 3 times, which failed. Here was the info. It was just the start. Then the warning was happening that the application server actually wanted to do a failure handling, but then the failure handling failed because of the runtime exception. So this is very useful, because I can use this ID for end-to-end tracking. When I look, for example, in the API gateway now for the same transaction ID, I can find that here, okay, all components in that chain I can trace back with the same ID. So here I see the application, the API gateway returned actually a 500 to the user. And I can see exactly the number of bytes, the processing time, which server has been requested to fulfill that request, and. So it means I can really do with this search in LTS end-to-end tracing through all the components. This query here up, where I just pasted this is a very powerful query language which you can use. You can not only look for unique IDs, you could also do you can look for something like for example, you can define queries, give me everything with a status of 500, give me everything which was a get method, and only for specific APIs. So you can build such kind of queries here. It's very useful, I would say, to do this. In the Help Center, you will find also a lot of helpful information, how to build these queries, what are the operators, how to escape characters, and so on. You will find that here. It's really a powerful tool to use. I also wanted to show quickly here what we can do with this quick search. The quick search is, for example, I have here the firewall attack log activated in my tenant. And you can see with these filters and with this quick route, for example, how powerful it is. So I can find out how many permits and denies the firewall has done. I can, for example, find out the attacks which happen on the firewall, which are protecting the backend system of the API gateway. Where did they come from? Most of them you can see here. You can filter. You can also access the level, what critical and medium and low attacks was been there, and you can then even define filters for yourself. Where you can say, give me all permitted actions, and then you can go and say, give me everything which got permitted of the end level is equal critical. And as you can see, critical operation should be not permitted. In the beginning, the cloud firewall was just in observation mode, but then we activated it for intrusion protection. And since then, no log anymore or no attack was allowed of the classification of critical. So this is also good for us. The backend systems are safe now. All right, the last thing I wanted to show is the quick search. You can refine these queries, save it for yourself, and so you can always run them. And I wanted to show the log alarm shortly. So as you remember, with the gateway, we produced failures, which was not handled, so runtime exception, and we one time produced to run it to a throttling interface. So what we have done is we monitor the log files itself with LTS, and as you can see, it detected the situations for us. So we have defined log alarms in the system. These log alarms are, for example, monitor failure requests and throttling requests, and it classifies those alarms. I shortly maybe just show here how to do this. The log alarm rules you can create with a name, and then you can define what are the criteria? The same way you do it on the LTS console. When you look for something, you can define multiple streams, what all needs to be searched. And then you can define a query interval and how long. As it means, for example, every hour the logs have to be searched for this criteria. And if, for example, 5 of these conditions you're looking for are found in the log files, then please send me an alert. You can even do it in a way that you activate a clearance to say that, okay, when this condition is activated for more than for 1 hour, consecutive 4 hours, then you can say, inform me also if the condition is being released. So if you maybe fix the problem, if maybe some countermeasures are being taken, the alarms then automated are deactivated with an alarm clearance. So this is a I would say quite important feature for the operations teams, that the log files can be monitored as well as the fail condition as well as the clearance conditions of alarms. All right. With that already, I want to stop the deep dive of the API part. Then let's go into the deep dive for the container part.
Yeah, thank you, Christian. I have to be real quick, so let's deep dive into the architecture of my part of the presentation. As you can see, I have a pre-built Kubernetes cluster, which I have already deployed to avoid wasting your time here. I have a node pool with 2 nodes on which I have installed the IC agent to collect the logs from my containers. One's from standard out and one from the container file system, and also the logs of the node itself. We will then look at the logs via the LTS console and then make a few queries via the API before I give you a few examples of how or you can visualize the logs in Grafana or use them in third-party tools. As I said, this is a pre-built CCE cluster, nothing special here. The most important part is the annotation. With that annotation, the IC agent is installed automatically in your Kubernetes cluster. Here I have defined the node pool with 2 nodes and the containerd runtime, nothing special here. Of course, I need the kube configuration file to access my Kubernetes cluster. And if I have everything made everything right, I have the kubeconfig file, which I exported in my kubeconfig environment variable. And if this is working, I can now access my Kubernetes cluster here. Okay, then how can I integrate my CCE cluster in LTS, or how can I collect logs with LTS from a CCE cluster? For that, I have prepared some code snippets to save some time here. At first, you will need a log group for your CCE cluster. You have to give it a name with this K8s log prefix and your cluster ID. Oh, sorry. The cluster ID you can get from the object here, which you have previously defined. And you have to define the TTL in days, of course. Secondly, you need a host group to group your Kubernetes nodes in a host group. Christian explained it very well. Again, this K8s log prefix with your cluster ID. Type Linux, and you can filter by label, for example. If you have this label, the node is automatically joined in this host group. Next, you will at least you would have to have at least 1 log stream to collect your logs from your CCE cluster. The most I would say the most common thing is to collect logs from standard out, because this is the default case. Every Docker image is logging the logs on this standard out stream. Okay, if you have the log stream ready, of course you have the group ID here, which you can get from this resource here in the previous example, and you have to give a stream name. You can choose every name you want, but in this case, I have created this prefix and again this cluster ID to different than in the LTS console. If you have the log stream ready, you will need a ingestion rule for that, to ingest, to collect your logs from your CCE cluster. For that, I've created this code snippet here. As Christian mentioned, you can see all the examples in community article. Okay, this is the log ingestion configuration. You have to give it a name, of course, the log group ID, log stream ID, host group ID, the cluster ID. The most important part is here the access configuration. You want to collect the logs from container standard out, and here you can decide if you want to only collect standard out and standard error, or both of them, or one of them. Okay, and here I have given you a few examples to filter your logs. You can filter, for example, only by namespace. You can filter by pod name, by container name. You can filter by container labels. You can exclude labels, so basically an opt-out functionality. You can filter by environment variables, exclude by environment variables, and Kubernetes labels like pod labels and deployment labels. So if I have made everything correct, then I can approve can deploy my Terraform code here. And you should now see we have 4 resources resources created. And if I check them now in the LTS console, you should now see a new log group here. And if I open this log group, you should see the previously created or defined log stream name. Everything I do with Terraform or through the API, you can do, of course, via the console. So for that, to show this quickly, I can modify my ingestion rule here. The CCE cluster, the log group, the log stream name. Here's in automatically dependency checker. All dependencies are met or prerequisites are met. I have the ACH installed and a host group is existing with this identifier. This is my host group. As I said, I have two nodes in this host group. Here's the name of the collection. I want to collect standard output from the standard output stream, and I have no filters defined here. The log structuring, Christian has explained very well, so I can skip this part for this example. And if I now check the log stream, we should see we have some actual logs here. These are, I wanted to show you first I have deployed a pod to the cluster, which, this is basically a pre-built random logger or a pre-built Docker image on the Docker Hub, which generates random logs on the console. To show you that, these are the logs. So random time, random logs are generated, and you can collect these logs here in the LTS console. Now you could structure your log a little bit, of course. As I said, Christian has explained this already. So then next example is not so common, but you can do this as well. You could collect files from the container file system itself. So if you have an application which does not write the logs to standard out or standard error, if the application is write the logs in, for example, in warlog or anyhow or anywhere, you can collect the logs from there as well. And for that, I need another log stream. Of course, you could collect it in the same log stream, but for the overview, it's better to create a dedicated log stream for that. This is the log stream. Container file, stream name, container file dash cluster ID. Similar example, or similar to the first example. Now let's create the ingestion rule for that. This is the ingestion rule. The This is the same, similar to the first example. The access config is a little bit different now. The path type, in this case, it's a container file. And here you can define the path where you want to collect the containers logs from. Yeah. If you want to collect more than one container log, you can define it with this wildcard expression here. Okay. Then let's deploy it to the OTC. As you can see, we have now 2 new resources. If we check them on the console again, this is our log group. Now here the new log stream appears. And if you check the ingestion rule, here you can see the newly created ingestion rule. To show you this quickly, I have created a simple pod. It's just a busybox image, and I created a loop to write random logs to var container demo log. To show you this on the console as well, I will log into the container and do a quick tail here. So as you can see, every 2 seconds, a random log is created here. If we check this now in the log stream, you can see you have now logs here in the logs stream. And now you can, structure your log. As you can see, here is the path file. This is the most important part here, where the logs are collected from. Okay, this is this example. Next example would be, you have, of course, Kubernetes worker nodes, and you want to collect logs from there as well. For that, you may guess it, we need another log stream to collect the host file logs. Similar to the other examples, group ID, stream name. And here is the ingestion rule for that. As I said, similar to the other examples, host file as a path type. And now I want to collect from the node under the var log audit folder, the audit log. It's just an example. Yeah, okay. So, and if I have made everything correct, let's deploy it. To our LTS service. And as you can see, here's the newly created log stream. If you check the ingestion management rule, you can see here's the host file rule. And to show this quickly, I have logged into my node via SSH. And if I check now the var log audit log, you can see you have multiple logs in this audit log. And if you check this, then in the LTS console, you can see these logs are collected as well. And of course, you could collect multiple logs from your node file. Okay, now to give you some examples closer to reality, I have prepared an example with Argo CD. Maybe I can share this. Some of you will surely know this tool. Argo CD is a GitOps tool that allows you to deploy your application from a Git repo. One concept of Argo CD is the so-called reconciliation, which you can think of a kind of health check. So every 3 minutes, your application is checked for changes in the Git repository. And if necessary, the target state is restored. Okay, let's take a look at this example. I have created previously a log stream for that, a dedicated log stream to structure a log, of course. It's called the Argo CD applications. Let's check the ingestion rule for that quickly. This is another cluster now because I use it for my real world examples. All the prerequisites are met. Yes, so now I want to collect the standard out and standard error in one stream. I have some filtering rules here. I'm only interested in pods which are running under the namespace Argo CD. And this is the microservices of Argo CD, which is responsible for the whole life cycle of your application. So I'm only interested for this example. I'm only interested in this pod. So this is my regular expression to met this pod. Next, I created, of course, a kind of structuring. This is, as Christian showed already, this is an example log file. And the most important part in this case is the message. Reconciliation is completed. The application, of course. And later on, I will show an example in Grafana for the time it took to reconcile your application. Index settings are created automatically for you. And if you now check the log stream here, you have some logs here. If we, for example, check the application, these are all the applications which I manage with Argus CD. This should match the same as in the Argus CD GUI here. And as you can see, there's one application in unknown state. So let's see how we can not fix it, but to figure this out through the logs. For that, I will not use the LTS console. I will use the API for that. For that, I will share my Postman here. I have created a few example queries here. This is the API which are interesting in this case. You have to give some mandatory parameters here. This is basically the group ID of the log group I want to query, and this is the log stream ID. So this Argus CD application log stream, And then you have some mandatory body parameters. Of course, the authentication via the XAuth token it's clear. I do not show you this. And then I have some mandatory parameters, for example, the start and end time. I get this parameters from a little pre-request script, I would say. This is just the current timestamp and 12 hours in the past. So this is that I do not have to do this manually. Then I'm interested in the message application status is synced. So if this is basically the successful reconciliation of your application. So and I want to count this. I want to count the logs. As I said, in the last 12 hours, I have successfully this amount of reconciliations. And I'm also interested in the unsuccessful reconciliations. And for that, I have created this query here. And same query or similar query with a different application or with a different message. I have indexed this field as well here. So I'm looking for the application status is unknown. Okay, this is interesting, but if you want now to, let's say visualize your logs a little bit, I have created a Grafana dashboard for that. Let me show you the Grafana dashboard. I guess, many of you will know this Grafana tool. It's just for visualizing data. I've created this Argus CD dashboard, and as you can see, I have 3 panels here. The first panel is the Argus CD reconciliation panel. And if I check this here, this is basically the same request as in Postman. I have the API, I have the header here. This is a built-in variable. This is exchanged with the value you choose here. So the same as Postman 12 hours ago. Yes, application status is synced. And I'm interested in the count. I want to show the count here in this panel. This is the first query. This is the green query, as you can see here, the successful reconciliations. And the second query, the yellow query, is the failed reconciliation, or let's say unknown reconciliations. So same query, as I said, same in Postman, but this time with the application status is unknown. So and with that, you get this nice and shiny overview in a kind of pie chart. Of course, you can choose another one if you want. Okay, you're not only interested in the successful and failed reconciliations. You want to know, of course, which of your applications is failed. So for that, I created another panel. Let's quickly go into that. Do I have the time? Yes, I have. It's basically the same query as in the unsuccessful reconciliations, with one exception. I'm not interested in the count. I go through the JSON object, as you can see here. Maybe I can show you this quickly in the Postman. So I go through this JSON object logs, labels, And then I have created this label application secret in this case. Okay, to show you this, only this application is now presented here in the table. And to transform it a little bit or to make it a little bit more pretty, I have grouped by the failed applications so that you do not see the multiple times the secrets is the application which is failed. And with that, you have then this failed application panel. And of course, you could, let's say possibilities are endless. So these are just examples. I want to make this clear. These are just examples and ideas on how to visualize your logs a little bit here in Grafana. For that, I have chosen the reconciliation time. Let's deep dive into it in the Postman. It's, of course, the same API. I want to query my logs, but now I'm interested in the keyword reconciliation is completed. And for that, I have indexed the time. As you can see here, the time in milliseconds. And now in Grafana, I use this gauge panel to visualize it a little bit. Here you can see the request parameter as in Postman. And now I built a table with, where is it? Here. I built a table with all the labels and I transform it a little bit. For example, I have to ensure or convert the time milliseconds field into a number because it's a string and filter it a little bit. And then I built the average of all the values. And then you have this nice and shiny gauge here, which shows you the average reconciliation time of your application in milliseconds. As I said, these are just a few examples to give you an idea of what you can do with the LTS and with the LTS API and with the integration in third-party tools. And with that said, I would hand back to Christian.
Yeah, thanks a lot, Sandro. It was really nice to see what you all can do. And I think, this is a great way to build this kind of dashboards for mission control centers based on log files that you really understand what's happening in your system. Last but not least, I want to shortly dive into the area of the billing of LTS service. So we have three major parts in the billing. In LTS, we look for the data ingested, as more or less for the storage of data, the log data, then the read-write traffic into the LTS service and into the index. I have to maybe shortly explain this. So LTS stores the log data itself, whatever you send in. For example, you send in 100 terabyte of data into this service, this 100 terabyte of data and then are indexed. So this indexing means you structure the logs with fields, with parameters, and this is what we call the indexing. So when you, for example, look for like the alarm rules, what you have seen before, when you look for a specific error code into a log file which is passed, then the query goes to the index. And if you just want to do a simple query on the raw log data, then it goes to the unindexed data. So two examples are here that you get a little bit idea what's the costing around it. Every item, the read-write traffic, the read-write index traffic, and the storage, they have a 500 MB free quota for every month. So every customer can use the service for free with a 500 MB quota. And when you more or less ingested 510 MB into the service per month, then this 10 MB are charged on top of it. There's in the configuration of LTS, you can also configure that you don't want to go into the paid model of then you can automatically, then the service ensures that it automatically stays under 500 MB. But this also means that you're losing your log data when they are reaching 500 MB storage. So this is this, and then maybe what is coming next, what we are working on. So right now, what is on the plan for this quarter is we want to release a new feature to also get the master logs of the CCE integration. Then the anti-DDoS service will be integrated, that you get automatically the logs in LTS from the anti-DDoS service. And then there is something what we call the so-called LTS ingestion API, because I have to explain this. This is a brand new product feature, and it is so cool because we have seen now how to get logs from CCE clusters. We can collect it from function graph. We can collect it from ECS service. But what if this is not enough? So you can also decide that you want to use the LTS itself from the API. So you can stream and create your logs custom without having any ECS service or Kubernetes cluster running. So you log out from a very different source. So this is a so-called third-party integration. So you can send logs from anywhere, more or less, to LTS. And this is the so-called LTS ingestion API. This has a super cool feature. It's even allowing a nanosecond precision sending. That means that you can use it from multiple sources. Also, you can, for example, connect 100 systems to it and send log data even in nanosecond precision that you can exactly identify at which time which system has sent what informations. Then we work on extra region hosts in the next quarter. This means that you then can enable even log data collections from other cloud providers or from your local data centers. And in the next releases of Terraform, you will see more and more features to be activated for the LTS. So we have seen already today the Terraform integration is already quite powerful. So thanks to Sandro, he demonstrated us. One remark, this is a very new Terraform provider version you need. This is 1.36.35. It's the latest one. It just came out. It's brand new. So feel free to use it. And this comes me now to the end. So you will find 2 articles in our community. The first one, the upper link, you will find all the examples we have used today. The Terraform parts, the parsing and the regular expressions I've used, and you even see, for example, how to use the LTS ingestion API with a nanosecond precision with an example, as well as you see one example how to use function graph, for example, because function graph is funny. If you remember the first slide, it was mentioned 2 times. You can use function graph when your functions report logs into LTS. That is that you can collect logs from the functions you develop, but you can also use function graph to do a custom processing of your logs. So for example, if you want to analyze logs which I have stored in LTS, you can use function graph then to further parse it, to further build applications on it. That is also a very nice feature. And this is the second link I've posted here at the bottom. I hope it was interesting for all of you. I hope we could bring in the features and the functionalities what we have in LTS. To be honest, there are so many and it's so powerful a service. So we could only show and demonstrate a couple of them, but I hope it was interesting.
All right. Thank you a lot, Christian. And also thank you a lot, Sandro, for the nice presentation and for the very impressive live demos here. Then the last point here, you already have it on the slide, Q&A. Here's one question related to the billing part. It's stated like, I am not very clear how the billing works. Daily log volume is billed. Can you elaborate on this example? So how is each example item, they're really going into the LTS billing elements there. So maybe a few more words about the billing.
Okay, also more or less, also the example which I showed, maybe I can also go there into the slide. So this example here, for example, shows that you send 100 MB data into the LTS. So now you have to think on a 30 days period because we are billing 1 month of it. So and you store this data for 30 days under this assumption. So you can also decide to store your log for 60 days or for 90 days. This means it will always accumulate until your log files are taken out from the system and from LTS again. So this is a little bit the challenge that you have to know how long the retention period of your logs will be, also how long the LTS stores your log. So this is the first information. Also it means 15 days in this example, and you send 100 MB per day. So at the end, the overall storage of a full month covers 1.5 gigabyte. If you would double your retention period to 30 days, your overall storage will also be doubled then to 3 gigabytes. So this is how these are the two important parameters. How many logs do I send per average per day? And how long do I store this data, which is called the retention days? So by the way, the LTS supports to store your log data to maximum 1 year. And after that, you can also decide even to export it to OBS. But 1 year is right now the maximum. The second part is then, this was just the ingestion part. So you send data, they are stored, and they are indexed. So right now, no one has worked with this data. Now you would start on the console, or like the example what Sandro showed, that with the API or with the console, you start analyzing the logs. And that would be then the second part, that you say, how often or how many MBs do you extract of this log data? So for example, when you build a query which runs every minute, which every time extracts 1 MB of the data, then you have over the month a traffic accumulated with that amount of megabytes then, like in this example, 1.5 gigabyte. So this is how it works.
Mm-hmm.
And 1,500 or 15,000 queries, always taking 0.1 MB of firm, then defines this based on this pricing. I hope that was clarifying the question.
One very last question, how to integrate LTS to other services like CTS and WAF? Is this already supported?
Yes, so on the WAF we are also working on that. The classical WAF has not yet integration, but the new WAF has it, and the CTS is also already supported. So you can log all the audit logs into, you can forward it to LTS to also store it, for example, for 1 year, and then you can see what all has happened in your audit log in OTC.
All right. If you still have some open questions, this community webinar is hosted by the Open Telecom Cloud Community Portal. You see here also 2 big screenshots related to community articles to this topic here. So if there is any open question still left, please go to the community portal, write your question therein. If it's about today's topic of the webinar, or if it's overall a completely other Open Telecom Cloud related issue, you can always use the community portal. Our experts are there to help you. And with this, I would say, yeah, thank you a lot for presenting, Christian. Thank you a lot for presenting, Sandro. Thank you a lot to everybody here still in the call for joining today, and see you again next month for the next Open Telecom Cloud Community webinar. So stay tuned and see you again in the next session. Thank you and goodbye.
Bye.
Bye-bye.